Hey everyone, and welcome to today's Explainer. Look, if you've ever spent even 5 minutes on a construction site, you know the technical jargon flies around fast, right? Well, today, we're going to demystify some of the absolute most common, yet literally foundational numbers you'll see out there. Let's just dive right in and definitively decode concrete grades. So you've definitely heard them tossed around. M20, M25, M30, maybe even higher depending on the project. People on site just rattle them off like we're all born knowing exactly what they mean. But seriously, what do these numbers actually represent? Are they just some random code an engineer made up, or is there hard, testable science behind them? Well, spoiler alert, understanding this simple little code is basically your master key to grasping the structural integrity of an entire building.
Okay, before we crack the code, let's just ground ourselves for a second. Concrete is, quite literally, the foundation of our modern world. I mean, from the house you're sitting in to those massive downtown high-rises, the bridges we drive across, and the roads we use every single day, it is everywhere. But here's the catch, and this is super important. Not all concrete is created equal. It's specifically divided up into different grades. And those classifications, they are based entirely on one critical factor: strength. You know, you simply can't pour the exact same mix for a backyard patio as you would for a heavy-duty highway overpass. It just doesn't work that way.
Right, so let's break down this naming system, starting with that very first letter. Honestly, what I love about this is how beautifully simple it actually is. That M, it just stands for mix. That's it. It refers to the mix grade, meaning the specific recipe, the exact proportions of cement, sand, aggregate, and water going into that batch. It's essentially telling you, hey, this is a standardized formula.
But, a recipe is only as good as the final result, right? The second half of our code, the number right after the M, that represents the concrete's characteristic compressive strength. And we measure this strength in a unit called megapascals, or MPa for short. Now, compressive strength is exactly what it sounds like. It's the absolute maximum downward crushing load that the hardened concrete can take before it finally cracks and fails. So naturally, a bigger number, that just means it can hold up a significantly heavier load.
Now, hold that thought, because we have to talk about a magic number in civil engineering: 28. Why 28? Well, because you don't just mix concrete, pour it into a mold, and go test its maximum strength the very next morning. That's not how it works. Concrete actually takes time to harden through a chemical reaction called hydration. So the absolute crucial detail here is that this characteristic compressive strength we're talking about, that target MPa value, it is tested exactly after 28 days of curing. That 28-day mark is basically the universal timeline to prove the mix actually hit its design strength.
Okay, let's put the pieces of the puzzle together here. The formula becomes crystal clear once you see it. An M20 mix simply means that after 28 days of proper curing, that concrete is guaranteed to have a compressive strength of 20 megapascals. Boom. M25 gives you 25 megapascals, and M30, you guessed it, a solid 30 megapascals. It is such a beautifully logical system once you know how to read it. That number is literally telling you exactly how strong your foundation is.
Section 2. Concrete Applications. Where to use which grade.
So we've totally mastered the theory, right? But let's actually see how this plays out in the real world, because knowing the strength is great, but knowing where to correctly apply that strength is what actually keeps a building standing. Think of this breakdown as your ultimate on-site cheat sheet. Let's walk through it together. First, we've got M20. This is your absolute go-to for standard residential houses. We're talking foundational slabs, basic beams, and columns in a normal single-family home. It's plenty strong for everyday living. But step it up to M25, and now you're building multi-story buildings. You're dealing with much heavier structural members that have to support extra floors and transfer a lot more weight down into the ground. And finally, M30 and above. Guys, this is the heavy-duty stuff. We are talking massive infrastructure, towering high-rises, huge bridges, and complex industrial structures dealing with immense loads. You literally scale the grade up to match the gravity of the project.
Now wait a second, we really need to stop and highlight a super crucial point here, because we've got to bust a massive myth that you see on sites all the time. A higher grade does not just mean dumping in more cement. I'll say it again. You cannot magically turn a basic M20 mix into a heavy-duty M30 mix just by ripping open an extra bag of cement and throwing it in the mixer. No way. That is a total myth. It'll wreck your budget, and frankly, it is absolutely terrible for the structural integrity of your pour.
To actually hit that higher compressive strength, you have to respect the engineering. Bumping up a grade requires a meticulously calculated mix design. That means the exact proportions of sand and coarse aggregates have to be perfectly tweaked. Secondly, the water-cement ratio. This is absolutely critical. Add too much water because it's quote-unquote easier to pour, and you will severely weaken the mix, completely undoing the strength of the cement. And third, the curing process itself. The exact way you hydrate and protect that concrete over those 28 days is what actually locks in the strength. It's a precise science, guys, not a guessing game.
So, after all that, what's our golden rule? The main takeaway. The higher the grade, the stronger the concrete. It's a direct, proportional relationship. An M25 mix is fundamentally designed to handle more compressive force than an M20 mix, assuming, of course, that all those strict mixing and curing rules we just talked about are actually followed to the letter. It really is the universal language of structural safety.
And that brings us to the end of today's explainer. A huge shout out to JK Civil Site, which is where the source material for this breakdown comes from. So if you want to keep leveling up your practical construction knowledge, definitely go check them out. But before we sign off, I want to leave you with a quick thought. Now that you fully understand the crazy, precise balance of mix design, water ratios, and 28-day curing required for something like an M30 mix, how confident are you that the massive concrete bridges you drive over every single day were mixed, poured, and cured with absolute perfection? Something to think about next time you're stuck in traffic on an overpass. Keep learning, stay curious, and I'll catch you in the next explainer.